Welcome to the DIY Honda Garage channel. The DTC P2097 indicates a rich fuel condition in the post-catalyst fuel trim system for the Honda Fit models from 2015 to 2020. This means that the ratio of fuel to air is higher than optimal after the catalytic converter, indicating that the engine may not be running efficiently. The primary component involved is the air-fuel AF sensor, which measures the amount of fuel being used compared to the air entering the engine. It is located pre-catalyst within the exhaust system and plays a critical role in adjusting the fuel injection. The secondary heated oxygen sensor, HO2S, also plays a part in monitoring exhaust emissions after they have passed through the catalytic converter. Diagnosis and troubleshooting should begin by checking for other potential diagnostic trouble codes, DTCs, that could indicate related issues before focusing solely on P297. DTC P2097, defined as post-catalyst fuel trim system too rich, indicates an issue with the fuel mixture after the exhaust gases have passed through the catalytic converter. The air-fuel sensor, AFAC sensor, is responsible for detecting the fuel and air mixture before combustion. Its primary function is to optimize fuel injection rates. The secondary heated oxygen sensor, HO2S, checks the composition of exhaust gases after they exit the catalyst. Its role is to ensure the emission levels meet regulatory standards. Both sensors are located within the exhaust system, and any discrepancy in their readings can lead to a rich fuel condition. Therefore, accurate readings from these sensors are crucial for diagnosing the P2097 code. Several factors can lead to the occurrence of DTC P2097. A faulty air-fuel AF sensor can cause inaccurate readings, leading the engine control unit to inject too much fuel. Similarly, the secondary heated oxygen sensor, HO2S, could be malfunctioning, providing incorrect feedback about the exhaust gases leaving the catalytic converter, thereby affecting fuel trim. Clogs or leaks in the exhaust system between these sensors can also hinder the effective monitoring of exhaust gases. Additionally, issues in the fuel system, such as bad fuel injectors, can contribute to a richer than ideal air-fuel mixture. Finally, general engine performance problems like misfires or issues within the ignition system can adversely affect fuel trim and lead to the setting of this DTC. Vehicles with the P2097 code often exhibit several noticeable symptoms. Owners may report poor fuel economy due to excessive fuel being consumed as the engine attempts to compensate for the incorrect air-fuel mixture. Increased exhaust emissions are often linked to an overly rich mixture, which can lead to potential environmental violations. Additionally, a rough engine idle can occur, which may manifest as vibrations or inconsistency when the vehicle is stationary. The illumination of the check engine light is another common symptom, as it serves to alert the driver to problem codes such as P2097 stored in the vehicle's onboard diagnostics. In some cases, engine misfires may also occur, particularly if the problem affects individual cylinders. For the first step in troubleshooting DTC P2097, it is essential to verify the problem accurately. Begin by turning the vehicle to the on position, ensuring that the engine isn't running. Utilize the Honda Diagnostic System, HDS, to clear the DTC and evaluate the vehicle's performance. Once cleared, start the engine and hold it at 3,000 RPM without any load until the radiator fan engages. After this, drive the vehicle under specific conditions where the engine coolant temperature must exceed 158 degrees Fahrenheit, 70 degrees Celsius, maintaining speeds between 15 and 75 miles per hour for at least 70 seconds while keeping the engine speed under 4,000 RPM. Finally, check the OBD status for DTC P2097. If the HDS indicates a failed status, proceed to the next troubleshooting step. If passed is indicated, the system may be functioning correctly, although continued checks for connection issues at the AF sensor, secondary HO2S, and the PCM are advisable. In the second step of the troubleshooting process, start the engine and hold the engine speed consistently at 3,000 RPM without load until the radiator fan activates. It's important to ensure that all electrical loads are turned off and the air conditioning, AC, is disabled during this process to obtain accurate readings. Using the Honda Diagnostic System, HDS, perform the cylinder AF test in the inspection menu and repeat this procedure 3 times to ensure the reliability of the data collected. An OK result indicates that the air-fuel mixture is functioning as expected, allowing you to advance to step 3. However, if the test returns a no result, it suggests potential issues with the air-fuel mixture, and further troubleshooting for DTC P219A should be undertaken. In step 3, the next focus is on checking the exhaust system for any leaks, clogs, or blockages that could contribute to the poor performance indicated by DTC P2097. Start by turning the vehicle off, ensuring safety during inspections. Carefully examine the area of the exhaust between the air-fuel sensor and the secondary oxygen sensor for any damage that might affect performance. Leaks can significantly alter the readings from the sensors, while blockages can prevent proper exhaust flow, both of which may lead to richer fuel conditions. If any issues are found during this inspection, they should be repaired or replaced promptly. If no leaks or blockages are identified, proceed to the next troubleshooting step for further diagnosis. The fourth troubleshooting step involves substituting a known good air-fuel AF sensor to assess whether the current sensor is faulty. Ensure all connectors are securely reconnected after replacing the sensor. Once the new sensor is in place, turn the vehicle to the on position and clear the DTC using the Honda Diagnostic System, HDS. To calibrate the system, perform the PCM idle learn procedure, which allows the engine control unit to adjust to the new parameters set by the replacement sensor. Start the engine and maintain it at 3,000 RPM without load once more, paying attention to any changes in vehicle performance. Finally, monitor the OBD status for DTC P2097. If the HDS indicates a passed status, the original AF sensor was likely the issue, and replacement is advisable. If failed appears again, the focus should shift to the secondary HO2S for further diagnostics. After completing the necessary repairs and component replacements involved in diagnosing DTC P2097, it is crucial to verify that the system is functioning correctly. Use the Honda Diagnostic System, HDS, for a final inspection, ensuring that all previous diagnostic trouble codes have been resolved. Monitor the system for any recurring DTCs that may indicate ongoing issues. Additionally, it is advisable to check all connectors to confirm that there are no loose terminals or poor connections, as these can lead to further errors. A test drive under normal operating conditions is recommended to validate that the vehicle performs optimally without triggering any warning lights. A successful test drive will provide confidence that the repairs have resolved the initial problem. To prevent the recurrence of DTC P2097 and maintain optimal vehicle performance, regular maintenance is essential. Periodically check the functionality of the air-fuel sensors and oxygen sensors as part of routine vehicle inspections to ensure they are operating correctly. It's also important to inspect the exhaust system routinely for signs of wear, leaks, or blockages that could cause issues. Keeping the engine operating efficiently through regular service checks, including oil changes and air filter replacements, can significantly enhance performance and fuel economy. Monitoring the quality of fuel being used is also critical, as poor quality fuel can lead to issues with fuel trim adjustments. Lastly, schedule regular diagnostics to catch any emerging error codes early, allowing for prompt intervention before they develop into larger issues. In summary, DTC P2097 relates to a rich fuel condition in the post-catalytic converter fuel trim system. Identifying and diagnosing this code requires an understanding of the critical components involved, particularly the air-fuel AF sensor and the secondary heated oxygen sensor HO2S. The troubleshooting process is thorough and demands close attention to detail, evaluating every potential factor that might contribute to the detected error. Regular maintenance and inspections play a vital role in preventing similar issues from arising in the future. By ensuring optimal performance and monitoring vehicle emissions closely, owners can maintain their Honda Fit's efficiency and comply with environmental standards effectively. Timely interventions and preventive measures will ensure that the vehicle remains in good condition for years to come. Please like and subscribe to the channel. See you next time.